హాయ్ స్టూడెంట్స్, ఈరోజు క్లాస్లో మనం కాంప్లెక్స్ నెంబర్స్లో కొన్ని ప్రాబ్లమ్స్ చూద్దాం. ఇఫ్ mod z ఈక్వల్ టు 2 అండ్ arg z ఈక్వల్ టు pi by 6 then z is. So we know that z equal to mod z e power I theta. So that is z equal to r e power I theta ante cos theta plus I sin theta, and this is called polar form of complex number. So z equal to r, that is mod z equal to r, that is 2 cos theta pi by 6 plus I sin theta, that is pi by 6. So therefore z equal to 2 cos pi by 6 root 3 by 2 plus I sin pi by 6, that is 1 by 2. So z equal to 2 into root 3 plus I by 2, that is 2 cancel, and finally z equal to root 3 plus I. So that is second option. And in this problem, if root of 2 plus 3i by 5 minus 4i plus 2 minus 3i by 5 plus 4i equal to a plus ib, then 41b square. So by taking cross multiplication LCM, 2 plus 3i into 5 plus 4i, 2 plus 3i into 5 plus 4i plus 2 minus 3i into 5 minus 4i by 5 minus 4i into 5 plus 4i, and that is equal to a plus ib. Okay. Now by simplifying, so 10 minus 12, 2 4s are 8i, 3 5s are 15i, that is 23i. Next, so 2 5s are 10, minus into minus plus I square minus, that is 3 4s are 12 plus 2 into minus 4i minus 8i minus 3i plus 5i minus 15i minus 23i by a minus b into a plus b. This is in the form of a minus b into a plus b, that is a square minus b square, 4i square, I square is minus 1 minus of minus plus 4 square is 16, that is equal to a plus ib. So 10 minus 12, 23i cancel, 10 minus 12 minus 2 minus 4 by 41, that is equal to a plus ib. So root of minus is I, root of minus 1 is I, so that is I. Root 4 is 2 by root 41, that is equal to a plus ib. So we write LHS in the form of 0 plus I, 2 by root 41 equal to a plus ib. By comparing real parts and imaginary parts, we get b equal to 2 by root 41. Now we have to find 41b square, that is 41 into b square, 4 by 41, 41 cancel, so 41b square is equal to 4. That is third option. In this problem, given that mod of z plus 2 plus 3i equal to 5, then the locus of z is. So we know that mod of z minus z naught equal to k represents a circle with radius k and center z naught. Okay na? So by comparing, the given is z by taking minus common, minus 2 minus 3i, that is equal to 5. Okay na? So by comparing with known formula, we get z naught, that is center, equal to minus 2 comma minus 3i, that is minus 2 comma minus 3, and radius r equal to 5. Okay, so that is fourth option. In this problem, given that I power 4n plus 1 plus minus I power 4n plus 5 is equal to, we know that I equal to root of minus 1 and I square equal to minus 1, I cube equal to minus I, and I power 4 equal to 1. I power 4n equal to 1, I power 4n plus 1 equal to I power 4n plus 2 equal to I square, and I power 4n plus 3, that is equal to I cube. Okay, so now given problem, I power 4n plus 1 plus minus I whole power 4n plus 5. So I power 4n plus 1, first term is as it is, and second term here 4n plus 5 is odd power. So minus power odd power is minus of I power 4n plus 5. Odd power of minus is minus. So I power 4n plus 1 is equal to I minus I power 4n plus 5 can be written as 4n plus 4 plus 1. So this is in the form of I minus I power 4n plus 1 into I power 1. So a power m plus n is equal to a power m into a power n. Okay. So I power I minus I power by taking 4 common. So this is in the form I power 4n. So that is 1 into I. So I power 4n is 1 into I minus I, that is 0. First option. And in this problem, given that sigma n equal to 1 to 200 I power n, so that is I square, I cube, I power 4 and so on, I power 200. So we know that the sum of first 4 powers of I is 0, and we have 4 elements of number of groups are here, n value is 200, and 200 by 4, by dividing 4 terms as a group we get 50 groups. So and each group is equal to 0. So 0 plus 0 plus 0, that is equal to 0. So here we have 200 powers, 200 terms. So 200 by 4, by dividing 4 terms as a group we get 50 groups, and each group is equal to 0, since the sum of first 4 powers of I is equal to 0, therefore equal to 0. ఒకవేళ ఇక్కడ n వాల్యూ కానీ ఆడ్ నెంబర్ అయితే 201 అయితే మనకి I మిగులుతుంది. In this problem, given that I square, I power 4, I power 6 and so on, 2n plus 1 terms. 2n plus 1 terms means odd number of terms. So by taking n equal to 1, we get 2 plus 1, that is equal to 3 terms. Okay, now? So we find the sum of first 3 terms, that is I square, I power 4, I power 6. I square is minus 1, I power 4 is 1 and I power 6 is I square. Minus 1 plus 1 cancel, I square is minus 1. Okay, so first option is right option. If I square plus I power 4 and so on 2n terms, that is even number of terms, and by taking n equal to 1 we get 2 terms, and the sum of first 2 terms, that is 0. So if the number of terms is even, the sum is 0. If the number of terms is odd, then the sum is minus 1. In this problem, if Sn equal to I power n plus I power minus n, that is 1 by I power n, where I equal to root of minus 1 and n is a positive integer, then the total number of distinct values of Sn. Okay, now so for n equal to 1, we get S of 1, that is I plus 1 by I. We know that 1 by I is minus I, that is equal to 0. For n equal to 2, S of 2 I square plus 1 by I square. We know that I square is minus 1 minus minus, that is minus 2. N equal to 3, S3 equal to I cube plus 1 by I cube. I cube is minus I, 1 by minus I, that is minus I. We know that 1 by minus I is plus I, that is 0. For n equal to 4, S4, that is I power 4 plus 1 by I power 4, that is 1 plus 1, that is equal to 2. So these are the 4 values of S1, S2, S3 and S4, and we know that S5 is equal to S1, S6 is equal to S2, S7 equal to S3 and S8 equal to 4, and recycle. Every four values are recycled. So the distinct values 1, 2, 0 same value plus 2. So therefore the number of distinct values of Sn are 3, that is third option. In this problem, given that mod of 1 minus I 1 plus 2i minus I is equal to x plus I by, then x equal to determinant of 2 by 2 matrix A, B, C, D is equal to AD minus BC. So then the given problem implies 1 minus I into minus I minus I into 1 plus 2i, that is equal to x plus iy. By simplifying, 1 minus I into minus I, that is minus I, minus into minus plus I square is minus 1. By multiplying with minus I, we get minus I minus 2i square is minus, so that is minus of minus plus x plus iy. So minus 1 plus 2, that is 1, minus I minus 2i, that is equal to x plus iy. By comparing real parts, we get x equal to 1. By comparing imaginary parts, we get y equal to minus 2. Therefore x equal to 1. In this problem, given that z plus 1 minus I equal to mod of z plus I minus 1 represents, we know that mod of z minus z1 equal to mod of z minus z2, then z is a locus of straight line. So in the given problem, we have z plus 1 minus I by taking minus common, minus 1 plus I, so that is equal to z minus 1 minus I. Okay, so this is in the form mod of z minus z1 equal to mod of z minus z2. So therefore represents a straight line. First option. And in this problem, given that z minus 4i plus z plus 4i equal to 10 lies, we know that mod of z minus z1 plus mod of z minus z2 equal to k, and mod of z1 minus z2 is less than k, then z is a locus of ellipse. Now mod of z1 minus z2, that is mod of 4i minus of minus 4i plus 4i, that is equal to mod of 8i, that is equal to 8 is less than 10. So therefore represents an ellipse. An ellipse. In this problem, given that z minus 1 into z bar minus 1 can be written as by multiplying we get z bar minus z bar plus 1, z bar, that is mod z whole square minus, by taking minus common we get z bar is 1. We know that mod z whole square is x square plus y square, and z plus z bar is 2x plus 1. So this can be written as x minus 1 whole square plus y square. So that is mod of x minus 1 plus iy. So that is z, x plus iy is z minus 1 whole square. So that is second option. In this problem, real part of e power I theta, we know that e power I theta equal to cos theta plus I sin theta. And in this problem, given that e power I theta, that is e power I theta is cos theta plus I sin theta. A power m plus n, that is a power m e power cos theta into e power I sin theta. So e power cos theta, e power I theta is cos theta, here theta is sin theta, plus I sin theta, theta is sin theta. So real part, that is real part, imaginary part, REIM. So real part equal to e power cos theta cos of sin theta. Imaginary part e power cos theta sin of sin theta. Okay. In this problem, given that z1 z2 are roots of z square plus az plus b, that implies z1 plus z2, that is sum of the roots equal to minus a, and product of the roots z1 z2 equal to c by a, that is b. Okay. And also given that origin and z1 z2 are vertices of an equilateral triangle. We know that z1 z2 z3 are vertices of an equilateral triangle that implies z1 square plus z2 square plus z3 square equal to z1 z2 z2 z3 z3 z1. So that is z1 square plus z2 square plus z3 square, origin that is 0, z1 z2 z3 is origin 0 0. So z1 square plus z2 square, that is z1 z2 whole square minus 2z1 z2, that is equal to z1 z2. So z1 plus z2, that is equal to minus a whole square minus 2, z1 z2 is b, that is equal to b. So a square minus 2b minus b minus 3b, that is equal to 0. So first option. In this problem, given that z1 z2 and z3 z4 are two pairs of conjugate complex numbers, then arg z1 by z4 plus arg z2 by z3. So that implies arg z1 plus arg z2 equal to 0 and arg z3 plus arg z4 equal to 0. Okay now. So now arg z1 by z4 plus arg z2 by z3, that is arg z1 by z4 is arg z1 minus arg z4 plus arg z2 by z3 is arg z2 minus arg z3. Arg z1 plus arg z2 is 0. By taking minus common, arg z4 plus arg z3 is also 0. So 0 minus 0, that is equal to 0. First option. In this problem, given that mod of z minus 4 by z equal to 2. Then maximum value of z. So z can be written as z minus 4 by z plus 4 by z. We know that mod of z1 plus z2 is less than or equal to mod z1 plus mod z2. So given that mod of z minus 4 by z is 2 plus 4 by mod z, that is mod z into mod z is mod z square is less than or equal to 2 mod z plus 4, that is mod z square minus 2 mod z less than or equal to 4. By adding 1 on both sides, mod z square minus 2 mod z plus 1 is less than or equal to 5. So this is in the form a square minus 2ab plus b square. So mod of z minus 1 whole square is less than or equal to 5, and that implies mod of z minus 1 is less than or equal to root 5, and finally therefore mod z is less than or equal to root 5 plus 1. So the maximum value of mod z is root 5 plus 1, second option. And in this problem, given that mod z1 equal to 12 and mod z2 minus 3 minus 4 equal to 5, then the minimum value of mod of z1 minus z2. So mod of z1 minus z2 can be written as mod of z1 minus z2 plus 3 plus 4i minus 3 minus 4i. Okay na? So adding 3 plus 4i and subtracting minus 3 minus so adding 3 plus 4i and subtracting 3 4i. So that is, this is in the form of mod of z1 minus z2. One more line. Now you can write it as z1 minus, by taking minus common, get z2 minus 3 minus 4i. Okay. By taking minus common, 3 plus 4i. So this is in the form mod of z1 minus z2 minus z3 and is greater than or equal to mod of mod z1 minus mod z2 minus 3 minus 4i and minus mod of 3 plus 4i. Okay. So this is in the form of mod of z1 minus mod of, this is in the form of mod of z1 minus z2 is greater than or equal to mod of mod z1 minus mod z2. We use this formula in this problem. Okay. So given that mod of z1 is 12 minus mod of z2 minus 3 minus 4i is 5, and mod of 3 plus 4i, that is root of 9 plus 16 25, that is 5, is greater than or equal to 2. So therefore the minimum value is 2. In this problem, given that mod of z plus 2i is less than or equal to 2, then the greatest value, maximum value of z minus root 3i, it can be written as mod of z plus 2i minus I minus root 3. So mod of z plus 2i, by taking plus common, it can be written as minus root 3 minus I. So this is in the form of mod of z1 plus z2 is less than or equal to mod z1 plus mod z2. So that is less than or equal to mod z1 mod of z plus 2i plus mod of minus root 3 minus I. So given that mod of z plus 2i is 2 and mod of root 3 minus I is root 3 square is 3, 1 square is 1, that is 2 plus 2, that is 4. So the maximum value is, greatest value is 4.